it's a long time now since I've really done any work with servo motors. The ones that are up on the layout kind of work, and the code I wrote was a long time ago, and the wires I pulled were a long time ago, and they're all just sat there working. Someone mentioned to me the other day about managing the speed of a servo to slow them down. And it's something I remember I had looked at when I first plugged these things in and got them all set up, but I couldn't get it working properly, and uh, because everything worked fine when it was kind of full speed, and I had so much other stuff to look at, I kind of left it and thought, well, it works. I'll come back and refine it later. So maybe now is is later. I think the general idea of refinement is to slow them down a little bit, because by default, as these things are moving, that becomes a kind of a very familiar sound to anyone who's got these things running their turnouts. The sudden whap whap movement of the motor moving and turning the points. But this, even using the Adafruit, this is simply the Adafruit servo library. It's, you know, that sort of shows you connect 8 servos up to a board and it moves them all. But there's still very distinctively 2 different movements here with each board. There's the first sudden familiar whap whap, and then this second slower one. And I can't remember why I loaded this library up and set it going, but I did. Maybe I just wanted to find out which of my servos were broken and which ones were working. But that's got me thinking again to the whole idea of, can I slow these servos down on my layout for this slightly gentler, more sedate way of turning turnouts? And really, the way they implement this slower, smoother movement is really quite straightforward. It's just this for loop. So instead of saying go directly to the address I want you to go to the position, move your arm directly to the position I want you to move it to, I'm going to do it in these increments, and I'm going to move you one step at a time over 1,000 as quickly as I can, and you get that smooth movement from it. But that's not really directly translatable to a layout, because while those motors, as that one just did there, are going through the slower movement that maybe takes a second, the Arduino is doing nothing else. And for example, CMRI is polling that Arduino 4 times a second for the status of all of its sensors, for block detection and all that kind of thing. So I'm not willing to lock the Arduino up for over a second at a time, maybe 2 seconds at a time, just moving one motor when it's got other stuff to do. And the natural way to get around that is to, instead of have one for loop that dedicates itself to moving the motor from its initial position to its destination position, you kind of use because the Arduino, the sketch you write for it, it goes around in a loop anyway. So you write a bit of code, and there's plenty of examples on the internet, and I'll post a link to one I did that tracks where the motor is each time the Arduino goes through the main loop, and moves the motor on a little bit every time it goes through the main loop until the motor gets to the position it wants to get to. Therefore, each time it goes through the main loop and it's doing that, it's also doing everything else that it needs to do, responding to sensor requests and all those kinds of things. And initially, you seem to end up with exactly what you were looking for, in that if I use this as an example, this 5th one is a default quick one. And I think these 4 are, there's a noisy one there, but it's audible that they're just doing their quick movement. Whereas these first 4, I've configured to move more slowly. And if I click on this one, it might not be as audible, but I think it's these front 3 here. There's that one moving. And number 2 and number 1, and they move quietly, gently and smoothly, and appear to do what, that one's not configured yet, what I want. The problem, however, comes when things get scaled up. What I mean by scaling up is that movement might be nice and smooth, and at taking about a second might be the ideal time that I would want a motor to take to move from one position to the other. But that's just when one motor moves. And on my layout, I've got some double junctions, say, where if a train's coming down from the incline and it's heading onto the inside anti-clockwise line, then 4 turnouts need to move at the same time, especially under automation, because that section will be allocated and all the points in it at exactly the same time, and the instruction to move 4 turnouts will come to the Arduino at the same time. But moving 4 turnouts using that code is not the same as moving 1. And I've got some example routes. I've set a route here that will throw the first 4 turnouts, hopefully the nearest ones. And if I swap hands on here and come and point down here, I think it's these 4 servos here. So if I go to set all 4 of those thrown, I think it's this one. Maybe 5 seconds, and I've got to close them again. Maybe 5 seconds. But if I go, and they're obviously configured the same way, but if I go and throw just one of them, it takes just a second. So the more turnouts or more motors are being moved at the same time, the slower the process of moving them is. Because for a lot of people, that additional 5 seconds that it takes, or additional 4 seconds that it takes if 4 servos are moving, might be perfectly adequate, because points get moved perhaps more than 5 seconds before the train comes along, and that might be acceptable. But I did a video a little while ago on how using Raspberry Pi affected performance of automation in JMRI, and how if JMRI doesn't get a message back, a confirmation back within a certain amount of time that a turnout moved, and a train's moving fast and gets within a block of where that turnout was, then that train's going to get a red signal, and it's going to stop really unnecessarily, because the turnout should have moved quickly and it should have sent the feedback back to JMRI. So I know that when I'm setting 4 sets of points, I pretty much need them to move as quickly as if I was setting 1 set of points. So I modified my sketch. I sort of realized the first thing that the sketch needed to know is how many servos are currently moving. And I'm not going to go through all this because it would take too long, but there's a little bit in the loop now that kind of counts up how many servos are moving, because it compares them to previous values, so it gets an idea of how many were previously moving, and it sends them into this. There's also a value, I think I've called it a multiplier. It's probably ended up not quite being a multiplier, but that's what it's called anyway. And when we're moving with speed control, so remember, this is called from the main loop. So this is to move this function, this void will move a slow moving servo motor a little bit further in its journey. It won't do the whole movement. It might be the first, it might be the last, but it might be one in the middle as well. So it's going to do its little increment. So what I've done with this is to take into account the number of servos that are currently moving, and then increase the step. I talked about the step earlier, in that if I've got a turnout that has, say, a value of 1000 when it's closed and 1800 when it's thrown, then if I have a step size of 1, that means that every single step between 1000 and 1800 is going to be called. So it's going to, the servo's going to get moved to, the first time the iteration of the loop goes through, it's going to get moved to 1001, second loop 1002, and it's going to go through that. So it will take 800 iterations of the main loop to get the arm from one position to another. And when you consider that that still takes a second, that's really quite impressive. But again, once we start increasing the number of motors that we're moving at the same time, then that speed slows down. So effectively, what
this is doing is taking into account that there's how many servos are currently moving and increasing the step that each of those motors take to speed it up. Because if you've got a step of 1 and you're going 1001, 1002, 1003, then if you've got a step of 10, you go 1010, 1020, and you're going to get to the destination much more quickly. And really that's what this does. It takes into account there might be default step size anyway, and it allows it to increase by that. But what the script is doing is catering for, and of course the movement isn't as smooth. I have to accept that if I'm going from a step size of 1 and a nice smooth, I'm going up to a step size of 16, it's going to be a bit more jumpy, but it's still better than the wah quick movement, and it still gets everything there in a second. And I can't really think of a better way to achieve that.
Time to see now then what effect that will have on the servos themselves. So first of all, I'm just going to throw the individual servos to make sure that they don't behave any differently. The way I did the calculation and the multiplication was very much keeping in mind that 1 times 1 is 1. So if there's one turnout moving, then the multiplier will have no effect on its performance because 1 times 1 is 1. So they should still move in the same manner. I've kind of lined them up a little bit more intuitively now, so let's get them moving. That's still good. Roughly a second and much quieter. And I've set up these test routes. So I'll start with 2, then go to 3, and then 4. And I need to work out whether so everything's closed. So I'll start with throwing 2. And there's an immediate difference. If anything, they maybe be a little bit quicker than 1. And one of them moves more violently than the other. And then go to 3. That's not bad. Because the instruction always doesn't come at exactly the same time, it can come on different updates. Like one about to fall off there. Get a little nudge back on. But there's nothing sudden, and there's nothing too delayed either. So now let's go to 4. That one's going to fall off. There it goes. But still not bad, still within a second, still not sudden, and I'm not entirely sure I'm going to get it any better than that. So it's time to try it on an actual layout now. Just as a reminder then, before I update the code, of the noise and movement that we're talking about before the update. No mouse pointer. It's very quick, very sudden. And with the new sketch uploaded then, maybe quite reasonably surprising results, but I get this. And closing again. It does seem to still be doing them one at a time, in which case I wonder if the calculated steps are needed at all. Just out of interest then, after that strange behaviour, I thought I'd try taking the step jump out and see what it's like. So this is setting the route for that. That's it's still jumpy and annoying, just much slower. not sure if I don't just prefer it the way it's meant to be, but that one's definitely out. I've now updated a sketch that is on an Arduino that has single points. That last one only ever has crossovers on it. All 8 points are paired together. So I'm now moving just one set of points. And although it's quiet, it's still not smooth. I can hear the breaks in it. It kind of moves in chunks, and I guess that's just because the Arduino is actually busy, and sometimes loops run more slowly than others. It's when the PC's running properly, every quarter of a second it has to do a CMRI process, and it may be receiving updates, and it's doing a send as well, so maybe that slows it down a bit, because that's maybe every quarter of a second that the slight slowdown is, so the loop is probably taking longer every quarter of a second than it usually would, and that's what's giving us the breaks in there. But obviously that would be a lot more quiet with trains running round. I guess I've got to try that next. With the train running, then I'm just having a play with setting routes. The left hand side down there has the old motor speed on, so that's all kind of normal, whereas the ones up here have the new motor speed on. And I'm just going to try setting a couple of routes. And I mean really, the new slower speed stuff is more annoying than the original sweep, I think. It might be useful to someone, but I don't think it's useful to me. I think the Arduinos are too busy doing other stuff, at least mine are, to handle a smooth, slow move. So after all that, I think I'll probably go back to the normal full speed. It's been quite an interesting journey then to try and work out how these things work. It wasn't entirely successful. I have actually left it on the layout for a while, and I'm getting used to it because it's quiet when there are two, apart from that one, when there are two trains, full-size trains moving around the layout. Really all I hear now when these things move is the relays. But if they were moving like they are on this demo, it would be really pretty much perfect, and I'd be able to slow them down a bit too. But there are a number of factors that are making the movement jerky. The main one is how much the Arduinos are doing. The Arduinos have sensors attached to them, so they're getting 4 pulls a second from CMRI, from JMRI. They're having to process those, they're having to read the pins for all of their sensors, and then they're having to put that data back in the data array and send it back to CMRI through the RS485, and it's having to do that 4 times a second. So I think that's why the servos are making that burr kind of jolted movement, because they're basically Arduino's just doing too much. It's having some iterations through the loop where it has to do more than it does others, so it makes it jerky. I'm not really at this point, any more on this would be refinement, and I'm still kind of on the build stage, so I'm happy with it how it is. If I was going to look into it further, I think the easiest thing to do would be to have Arduinos that don't have any sensors attached to them running these servos, because then any Arduino node that doesn't have sensors attached to it doesn't get pulled by JMRI, CMRI, so it doesn't have to pull pin data and send stuff back, maybe clear out and maybe not have shift registers running off it as well, and then they would pretty much run like this. That was my experience, and they would run much more smoothly. Another option would be higher performance boards to see if that rules things out, or then there are these
servo controllers available from Merg, for example, that handle the movement themselves. So you just have the Arduino. It kind of takes the place of the PWM board, I guess. You have the Arduino sending message just to move to the board, and then the board's programmed to handle the move itself, which would be perfect, but not particularly expensive in terms of money, but expensive in terms of time for me at the minute. So again, the choice between continuing to build and refinement of it at the minute still goes with build.